All right, so we're going to get into lesson 5 in unit 3, and we're going to talk about scatter plots and linear relationships in unit 3, but we're going to define some things first. We're going to talk about bivariate data, and in order to understand bivariate data, you have to really understand what variate data is. And variate data is like an equation with one variable, right? If you want to know like what your pay is going to be at the end of the day, and you know what your pay rate is, right? And you know you worked this many hours, right? Well, then you know that you're going to have this much pay at the end of the day. Well, there's actually two variables in that equation, right? So say you didn't know what your pay rate was, right? So your pay rate, let's say that function is actually a function of your pay rate, your dollars. This is the dollars that you get per hour that you work, right? So your pay rate is dollars per hour, right? So this is actually bivariate data. It should be data. Data. Sorry about that. Data, bivariate data. Right? So bivariate data says, hey, this is data that depends on two different things, right? So it's data that measures two characteristics of a data set or a population, right? So this is data that measures, ASURES, measures two characteristics of a data set, right? We could have dollars per hour, we could have, inches per minute, right? We could have cycles per second, right? Often, a lot of the time, this is in a time unit, right? And this is in whatever you're trying to measure. But you could also have something like in diving, you could have something like N2 load rate per depth, right? Like for divers. Or you could have depth. You could have pressure depth relationship. You have pressure depth relationship. That's Boyle's law right there. Right? It's linear. All right. So that's a lot of different linear relationships things, right? But sometimes it's not a perfect relationship, right? Sometimes you get data that is, not exactly scientifically perfect, right? Sometimes you're taking survey data, right? And you're asking the number of, the test scores based upon the time spent studying, right? And you get, or you ask something like the number of hours slept versus the average football game score or something like that, that kind of things, right? And you get data points like this, right? Or here's another diving relationship. This is a perfect example, right? There's a thing called oxygen toxicity, right? And you get a partial pressure of oxygen, right? And then the occurrence of an O2 hit, because there's a DCS compression sickness, right? And as you raise the partial pressure of oxygen toxicity, or of partial pressure of oxygen in your body, people would start getting convulsions, right? And those are the occurrences, and then they would see a direct correlation of that, right? And they would see, and they would draw what they call a scatter plot, and that's what I just did right here. It was called a scatter plot, right? And it's a graph of, this is a graph in the coordinate plane, representing the bivariate data, right? That's data, right? Used to observe relationship. Used to observe the relationship of a data set within a data set. Within a data set. And then I drew a line of fit. Right? This line of fit is a line drawn in a scatter set between the bivariate data, or within the bivariate data, to show the trend, the trend line. Now, so you can see, like, I got this trend over here that I showed for like this time spent scattering, the test score, and the time spent studying, and then I have this one over here for the partial pressure and the O2 hit, and say I have like two sets of data. Say this data set A and I have data set B, right? And I can compare, like, one, I have a data set that's like this, and the data is kind of like loosely scattered, right? But you can tell that it's, you could kind of trend it like that. And then I have one that's like that's, yeah, that's an obvious trend, trending upward, right? Well, and they're both, like straight trending up. And then let's say I have a C one like this, right? And this one's kind of like, right, it kind of does something like this, right? Kind of does something like that, right? And then maybe I have something like this. It's like that, right? So these are the three different things that we can look at an association pattern, right? An association pattern. There's three different things you have to evaluate when you're looking at how the association is, right? There's three different characteristics when you're looking at the association within these trends, okay? So you're looking to see if it's linear or nonlinear, right? Look at these three right here, these four right here, this is D, right? A, B, and C are all positive. They're all trending upward. Well, first of all, A, B, and C, A and B and D, they're all linear. A, B, and D, they're all straight lines. A, B, and D are linear, right? Where C is nonlinear. C is nonlinear, right? It's not a straight line. This is more exponential. Okay. Now you're looking at the trend, right? A, B, and C are all trending upward, so they all have a positive trend. Right? And then now you're looking, and then C has a negative trend. So these are A, B, and C. A, B, and C. And then D has a negative trend. And D has a negative trend. Negative trend. Okay, and then you're looking at the strength. Okay, there's 3 different types of strengths. Right? There's a strong, a moderate, and a weak. Okay, so I would say that C and D are both pretty strong. Right? C and D are both pretty strong. I'd say B is kind of moderate, and then A is kind of weak. Right? And that's all based upon like the cluster, how close the cluster is, or how precise how precise the dots are. Right? The difference between precision and accuracy. Right? If I have a bullseye and another bullseye, there's 2 bullseyes, right? And I have a bunch of scatters right here. Those are my shots from my rifle, right? These are precise, right? And then that's accurate, right? This is precision, this is accuracy. These might not be clustered together as best as this, right? But these are closer to the bullseye, right? Precision, this is precision versus accuracy. Okay. So anyway, so we look at this. Our example here, right? This is the loose approximate equation, right? We can see it approximately intercepts the y-axis at about 60, right? So our y-intercept is 59.58, right? So almost 60, right? And this line of best fit slope, has a slope of about a half, right? So every change in y, every one change in y, there's about a change in x for about 2, approximately, right? Approximately, okay? Or that's congruent, sorry. Congruent is 2 wavy lines, approximately is 1 wavy line, okay? So we can say that this is approximately, approximately 1/2. The slope is approximately 1/2, right? And I would say that this is a positive, this is a linear, that way you can use this linear equation, right? And it's, I would say it's a moderate to strong association. So I'd say it's a strong association, right? And then it's positive, of course, positive trend, right? So that's how you kind of classify that. All right, so I hope that kind of makes some sense. Pretty straightforward and easy to understand. Take time to go ahead and pause if you'd like to copy those down.